This is question number 1. A body weighs 600 Newton on the surface of Mars. Determine the weight of the body at a height equal to the radius of the planet. In this case, we have to find out the weight of body at a height, that height is equal to the radius of planet. On that height, the same body we have to keep, and we have to find out weight of that body. So in solution, we can write as per the information, weight of that body on the surface of Mars, that is Wm, that is equal to 600 Newton. So that we know that weight is equal with mg. So as it is, we can write in a box the formula weight. M means weight on the surface of Mars, that is equal with mg. So weight Wm means weight of the object on Mars surface. Wh, it means weight of the object at the height h. So, and we know that height is equal with radius. So we have to find out Wh means weight of the body, same body with certain height from that surface, that is a Wh we have to find out, and Wh is equal with mgh. Okay, means acceleration due to gravity with h, gh. Okay, so m means mass of the body. So we know that by effect of the height on g, that is the height formula. Okay, so gh, that is equal with small g bracket r divided by r plus h bracket square. Gh is equal with g bracket r divided by r plus r. Instead of h, we are taking r. Okay, bracket square. So r plus r to r. So r cancel. So 1 by 2 square we are getting in the next stage. So finally we are getting gh, that is equal with g bracket 1 by 2 bracket square. So gh is equal with g into 1 by 4. So gh, that is equal with g by 4. Okay, so after getting this, we can multiplying by m to both sides. So we are getting mgh is equal with m into g divided by 4. So wh means mgh means wh, that is equal with wm divided by 4. So wh, that is equal with 600 divided by 4, because we know that wm means weight of that body on a Mars surface, that is a 600 as per the given information. So wh is equal with 600 divided by 4. So ultimately we are going on the next page. So wh, that is equal with 150 Newton. We are getting answer. So that is also wh means weight of body at height h, that is a 150 Newton. We can write in a statement at the last. Okay. Guys, we are going on the next page for the question number 2. So that question number 2 is, a body weighs 600 Newton on the surface of the earth. What is the gravitational force on it due to the height equal to the half the radius of the earth? Guys, in this case we have to find out what is the gravitational force on that body. It means we have to find out the weight of that body. Gravitational force on that body due to earth, that is equal with the body weight of that body. Gravitational force is equal with the weight. So guys, we have to find out weight, but they mentioned to find out gravitational force. So you must have to know, we have to find out the weight. Okay, otherwise you are thinking about the gravitational force and you are applying the Newton's law of gravitation, you will not get the answer for the gravitational force by that formula, Newton's law of gravitation. Here we have to find out gravitational force on it, means on the body. It means we have to find out the weight of body. So guys, we are writing as per the information. W means weight of the body on earth. WH means weight of the body at height h. So W, that is equal with 63 Newton. Okay, and we have to find out gravitational force, that is equal with weight, means weight of that body at height h. So, and as per the another information, height is equal with r by 2, means half of the radius. So we know that W is equal with mg and WH is equal with mgh. In this case, m is the mass of body and small g is acceleration due to gravity. Small g acceleration due to gravity, and small gh, that is acceleration due to gravity with height h. Now guys, Fg means gravitational force, that is equal with weight, and Fgh, that is equal with WH. Okay, so effect of height on the g means acceleration due to gravity, that is small gh is equal with small d bracket r divided by r plus h bracket square. So gh is equal with g bracket r divided by r plus r by 2 bracket square. So now in this case we have to add r plus r by 2. It means first r, that is has a denominator 1, and second that has denominator 2. So now we have to make a common denominator, so that's why I am multiplying here by 2 to the r by 1, means r into 2, 2r, and 1 into 2, 2. So we are getting in a first term 2r divided by 2. Okay. So guys, after this we are saying that, guys, after that we can say that 2r divided by 2 plus r by 2, that is we have to add in this case 2r plus r, 3r divided by 2. So ultimately r by 1 we are getting in the next stage, the numerator has r, that we are writing like r by 1, and at denominator we have 3r by 2, we can write in a multiplication like 2 divided by 3r. So in this case r, that is in a cross multiplication, will be cancelled. So we are getting 2 by 1 square. So gh is equal with g bracket 2 divided by 3 bracket square. Okay. So guys, we are going on the next page. GH, that is equal with G into 2 by 3 bracket square. So multiplying by m to both sides, we are getting mgh is equal with mg into 2 by 3 square. So mgh means wh, that is equal with mg means w into 2 by 3 square means 2 square 4, 3 square 9, so 4 by 9. So now we are putting value of w, that is 63. So with the help of calculation we are getting wh, that is equal with 28 Newton. So wh is equal with fgh means gravitational force, so that is equal with 28 Newton. So gravitational force equal with 28 Newton, we can write at the last. Weight of the body at height h is 28 Newton, and also the gravitational force is 28 Newton. So now guys, we are going for the third question. Question number 3. If the radius of earth is equal to 6371 kilometer, and if the earth is assumed to be a uniform sphere rotating at a rate of 1 rotation per day, how much the acceleration due to earth's gravity would change from pole to equator? So guys, in this case we have to assume that the earth is in a pure sphere shape, and radius of earth, that is 6371 kilometer, and that earth is rotating about itself, and we have to find out the acceleration due to gravity at pole and acceleration due to gravity at equator and difference between them. So guys, we are writing the information as per the data. Capital R, that is equal with 6371 kilometer. It means 6371 into 10 raised to 3 meter. And rotation rate, that is 1 rotation per day. So small n, that is a rotation per second, is equal with 1 divided by day. So 1 divided by 24 hours, 1 divided by 24 into 60 into 60. So small n, it means rotation per second, that is equal with 1 by 86,400 seconds. Now the acceleration due to earth's gravity would change from pole to equator, that is equal with g dash p minus g dash e. You learn this is in theory, that is g dash p minus g dash e is equal with r omega square. So by effect of latitude on g, we can write formula g dash p minus g dash e is equal with r omega square. And same thing, g dash p minus g dash e, we have to find out as per the information. We have to find out how much acceleration due to earth's gravity would change from pole to equator. It means we have to find out the difference between acceleration due to at pole and acceleration due to at equator. So that difference between acceleration due to at pole and acceleration due to at equator, that is equal with r omega square. So r omega means 2 pi n. In this case n is a rotation per second, so we can write 2 pi instead of n, we can put a value. So it means radius, that is 6371 into 10 raised to 3, 2 square 4, pi square, it means 3.14 square into n square means 1 by 86,400 square. So with the help of calculator, you will get answer G dash P minus G dash E is equal with 0.0336 meter per second square. So at the last you can write answer in a statement. The acceleration due to Earth's gravity would change from pole to equator is 0.0336 meter per second square. So guys, now we are going for question number 4, and that is also based on the latitude. Question number 3 and question number 4 are based on latitude. Only 2 questions from the latitude, very important questions. Now this is question number 4. If the Earth is assumed to be sphere rotating at a rate of 1 rotation per day, the acceleration due to Earth's gravity is found to differ by an amount of 0.0337 meter per second square between the pole and equator. Estimate the radius of Earth. So guys, in a previous question, with help of the radius of Earth, we found the difference between acceleration due to gravity at pole and equator. Here, with help of a value of acceleration due to gravity at pole and equator, difference between acceleration due to gravity at pole and equator, we have to find out the radius of Earth. So guys, as per the information, we can write the rate of rotation, that is 1 rotation per day. It means small n is equal to 1 by day, means 1 by 24 hours, 1 by 24 into 60 into 60. It means we are getting n means n is equal with 1 by 86,400. In this case, n means what guys? Rotation per second. So guys, as per the another information, G dash P minus G dash E, that is equal with 0.0337 meter per second square. Now guys, radius of the Earth we have to find out. So we know that the formula as per the effect of latitude, that is G dash P minus G dash E is equal with R omega square. So G dash P minus G dash E, that is equal with 0.0337 as per the information. R we are keeping as it is R because that we have to find out, and omega, that is equal with 2 pi n. So omega square, it means 2 pi n square. So we are putting a value 2 square 4, pi square 3.14 square, n square means 1 divided by 86,400 square. So after calculating, you are getting value of R, that is equal with 0.0337 divided by 4 into 9.8596 into 1 divided by 86,400 square, and after calculating you are getting answer, that is 6378 into 10 raised to 3 meter. So you can write in meter or either kilometer, no problem. You can write in kilometer. The radius of Earth, that is equal with 6378 kilometer, or either you can write in meter. Both are corrected. Both are correct. So guys, now we are going for question number 5. Now question number 5 guys, 2 identical isolated particles, each of mass 2 kg, are separated by a distance of 30 centimeter. What is the magnitude of the gravitational force on one particle on the other? If the separation between the bodies is increased by 50%, what will be the percentage change in the force? So it means here guys, we have to find out gravitational force. Okay, so basically guys, here we are using the Newton's law of gravitation formula. So as per the solution, we are considering m1 and m2 be the masses of each particle respectively. m1 is a 2 kg, m2 is a 2 kg, and distance between them, that is a small r, is equal with 30 centimeter. It means 30 into 10 raised to minus 2 meter. Fg means we have to find out gravitational force, and capital G is equal with 6.67 into 10 raised to minus 11 Newton meter square per kg square. Value for the capital G you must have to remember. Now by the Newton's law of gravitation, that is Fg is equal with capital G m1 m2 divided by r square. So if you are putting a value, that is capital G is equal with 6.67, m1 is 2, m2 is 2, radius is 30 into 10 raised to minus 2, r square, that's why 30 into 10 raised to minus 2 bracket square. So if you are doing a calculation, you will get answer Fg. We are going on the next page because steps are not mandatory guys, because you are using a calculator. So after this stage you can directly write the answer, you will get full marks. See guys, in nautical physics there is no compulsion to write each and every step, because after putting a value in a formula you have calculator, use of calculator and find out the correct answer with help of calculator. So guys, Fg means gravitational force, that is equal with 2.964 into 10 raised to minus 3 Newton. Now guys, if the separation means distance between two bodies is increased by 50%, so the new distance, that is r dash, will be 45 centimeter, because previous distance smaller, that is a 30 centimeter. So for the 30 centimeter, 50% is 15 centimeter. So 30 plus 15, 45 centimeter. So now the new distance, that is a 45 centimeter. So r dash, that is equal with 45 centimeter. So 45 into 10 raised to minus 2 meter. Now we are again finding the gravitational force, that is F dash G, because in previous we are using Fg. So here we are using F dash G, that is equal with capital G m1 m2 divided by r dash square. So now if you are putting a value like a capital G, that is 6.67 into 10 raised to minus 11, m1 that is a 2, m2 that is again 2, and r dash square, that is 45 into 10 raised to minus 2 square. If you are putting a value, so you are getting F dash G, that is equal with 1.317 into 10 raised to minus 9 Newton. Now guys, you are getting gravitational force with radius 30 with distance 30 centimeter and gravitational force with distance 45 centimeter. Now we are comparing and find out the percentage change in a force. So change in a gravitational force in a percentage, that is equal with F dash G, Fg minus F dash G divided by Fg, because Fg that is a greater than F dash G. That's why the previous one minus the new divided by previous one into 100. So you are getting answer, that is 55.56%. So we can say that 55.56 force decrease between the increase in distance, because see, gravitational force is decreasing. Here we have value 2.964, here we have value 1.317. So almost force is decreasing because distance is increasing. So we can write 55.56 force decrease because increase in distance. So now guys, we are considering on question number 6. A typical adult human has a mass of about 65 kg. What force does a full moon exert on such human when it is directly overhead with its center 3.78 into 10 raised to 5 kilometer away? Mass of the moon is about 7.5 into 10 raised to 22 kg. So now guys, here there are two objects, one is adult human, another one is moon. Distance between them is 3.78 into 10 raised to 5 kilometer, and we have to find out the gravitational force between them. So straight away we can write in solution, m1 that is the mass of the adult human, that is equal with 65 kg, m2 that is equal with mass of the moon, that is equal with 7.5 into 10 raised to 22 kg. Now r with the distance between them, that r is equal with 3.78 into 10 raised to 5 kilometer. So that is equal with 3.78 into 10 raised to 8 meter. So Fg means gravitational force is what? And capital G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. That capital value of capital G you must have to remember. Now guys, we are using the formula by the Newton's law of gravitation, that is Fg means gravitational force, that is equal with capital G m1 m2 divided by r square, and capital G that is equal with 6.67 into 10 raised to minus 11, m1 that is equal with 65, m2 that is equal with 7.5 into 10 raised to 22, and r square means distance square, that is equal with 3.78 into 10 raised to 8 bracket square. And if you are putting a value, you have calculator. Now use of calculator, find out the answer. We are going on a next page to get answer, means verify the answer. Now Fg means gravitational force, that is equal with 227.57 into 10 raised to minus 5 Newton. So guys, 227.57 into 10 raised to minus 5 Newton gravitational force moon exert on adult human. Okay. Guys, question number 7. Mass of the earth is 6 into 10 raised to 24 kg. Estimate the orbital radius of geostationary satellite. So in this case, we have to find out the orbital radius of geostationary satellite. It means distance between satellite and earth. Now guys, if you have to find out the radius, means distance between satellite and earth, because satellite is revolving around the earth. So we have to find out distance between satellite and earth, that is orbital radius. But if you have to find out the orbital radius, so you must have to know the time period for that geostationary satellite. Okay, and basically in a solution we can write this is a geostationary satellite, so the time period of it is 24 hours. So now time period is equal with 24 hours, that is equal with 86,400 seconds. So the mass of that satellite, that is equal to 6 into 10 raised to 24 kg. Capital G, that is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. By formula of time period, T square is equal to 4 pi square r cube divided by capital Gm. This is the formula for a time period. But with help of formula of time period, we are finding orbital radius. So guys, time period formula is T square is equal to 4 pi square r cube divided by capital Gm. So now we can modify this formula because we have to find out r cube. So the terms from the right hand side we are taking at the left hand side, and we are keeping r cube at the right hand side, and remaining thing we are taking at the left hand side. And if you are making an interchange between them, so you are getting the modified formula, that is r cube is equal with T square Gm divided by 4 pi square. So r cube, that is equal with r cube, that is equal with T square means 86,400 square, capital G means 6.67 into 10 raised to minus 11 into capital M means 6 into 10 raised to 24, 4 as it is 4, pi square means 3.14 square. Now guys, with the help of calculator you are getting answer, that is r cube is equal with 757,504.612763 into 10 raised to 17. Now guys, you have to take a cube root, and by taking a cube root you can directly get answer. That r is equal with 42311,825.27 meter. So in answer we can write the orbital radius of geostationary satellite is 42311 kilometer. So guys, now we are going on a question number 8. In question number 8, estimate the mean distance between sun and earth. It means we have to find out orbital radius, guys, using a Newton's law, assuming the orbiting the earth around the sun to be mass of the sun, that is equal with 2 into 10 raised to 30 kg. So guys, we are writing capital M, that is the mass of sun, that is our center for earth, because earth is revolving around sun. Now time period of earth, because earth is revolving, that is 365 days. You must have to know the time period of earth, that is 365 days. So T is equal with 365 into 24 into 60 into 60, because we are converting time period into second. So we are getting answer, that is 315,360,000 second. So now also you must have to know capital G, that is equal with 6.67 into 10 raised to minus 11 Newton meter square per kg square. So guys, after writing the data which already we are getting by the question, we are using formula of time period to find out the distance, means orbital radius. So we are writing formula of time period, that is T square is equal with 4 pi square r cube divided by Gm. So guys, it means if we are modifying, so we are getting r cube, that is equal with T square Gm divided by 4 pi square. So now if we are putting a value of T, that is 315,360,000, T square, it means bracket square, into capital G, that is 6.67 into 10 raised to minus 11, capital M, that is 2 into 10 raised to 30 kg, and dividing 4 pi square, 4 as it is 4, pi means 3.14 square. Now guys, with help of calculator you are getting answer, that is r cube is equal with 336,267.1.81377, and by taking a cube root you are getting answer, that is equal with r is equal with 1.4983 into 10 raised to 11 meter. Guys, you can write answer in meter, you will get full marks. Not necessary to convert in kilometer, but if you have capability, convert in kilometer. So at the last you can write answer in a statement, that is then the mean distance between the sun and earth is 1.498 into 10 raised to 8 kilometer. Now guys, we are discussing on question number 9. Question number 9 is what? A satellite of Mars has a period of revolution 459 minutes. Mass of the Mars is 6.42 into 10 raised to 23 kg. Determine the radius of the satellite's orbit. So guys, in this case again we have to find out the radius of satellite's orbit. It means that satellite is moving in one orbit, means revolving in one orbit, and we have to find out radius of satellite's orbit. It means we have to find out distance between satellite and the earth, means Mars, because here they mention the satellite of Mars. Okay, so guys, now we are taking first of all the time period of that satellite, that is 459 minutes. We are converting in second. It means 459 into 60, so time period is 27,540 seconds. Now mass of that Mars, that is as a center for that satellite, that is equal to 6.42 into 10 raised to 23 kg, and capital G, that you must have to know, 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now by the formula of time period, that is T square, that is equal with 4 pi square r cube divided by capital GM. We are modifying this formula and we are getting r cube, that is equal with T square GM divided by 4 pi square. So we are putting a if you are putting a value that T is equal with 27,540 bracket square, capital G is equal to 6.67 into 10 raised to minus 11, mass is equal to 6.42 into 10 raised to 23, so divided by 4 pi, means 4 into pi, that is 3.14, pi square means 3.14 square. Now putting a value in formula by help of calculator, you are getting answer, that is r cube, that is equal with 823,511.79157 into 10 raised to 14. Now after getting this answer, if you are taking help of calculator and finding cube root, you are getting answer, that is 937,241.689 meter. So if you have capability, write answer in kilometer, otherwise you can write answer in meter, that's okay. The radius of satellite's orbit is 937 kilometer. Okay. So now guys, this is question number 10, and in question number 10 we are understanding what we have to find out. The period of revolution of moon around the earth is about 27 days. Mass of the earth is 5.9 into 10 raised to 24 kg. Determine the mean distance between earth and moon. Again we have to find out distance, mean, orbital radius, so we are taking help of time period formula. So for that we require time period. So time period for the moon, that is 27 days, we are converting into second. It means 27 into 60 into 60, means time period is equal with 97,200 seconds. And mass for the earth, because earth is at the center for the moon and moon is revolving around the earth. Okay, time period we have to take that thing is revolving, and mass we have to take from the thing that is at the center. So mass of earth is 5.9 into 10 raised to 24 kg. Capital G is equal with 6.67 into 10 raised to 11 Newton meter square per kg square. By formula of time period, we are getting T square, that is equal with 4 pi square r cube divided by capital GM. So we are modifying this formula. We are getting r cube, that is equal with T square GM divided by 4 pi square. So r cube is equal with T is equal with 972 into 10 raised to 2 bracket square. Instead of 97,200, I am taking 972 into 10 raised to 2. If you want, you can take 97,200, it's okay, square, into 6.67 into 10 raised to minus 11. M, that is equal with 5.9 into 10 raised to 24. Now divided by 4 pi square, it means 4 into 3.14 square. So now guys, if you are putting a value in formula with the help of calculator, you are getting answer, that is r cube is equal with 9,42,738.1 162,603 into 10 raised to 17. Now guys, after getting this value of r cube, if you are taking help of the calculator and try to find out cube root, by taking a cube root you are getting answer, that is r is equal with 4. So guys, ultimately the value of r, that is equal with 445,512 kilometer. Guys, if you are writing answer in meter